This is the comeback of supersonic flight, faster than ever, quieter than before, and now targeting private aviation. Supersonic travel once vanished after Concorde, but a new wave of technology is bringing it back. This is how private jets are leading the return of faster-than-sound travel. 10. Tupolev. Tu 144. The story of supersonic aviation begins with the Tupolev Tu-144, the first passenger aircraft to break the sound barrier. It entered service in the 1970s and represented a major technological leap. But the reality behind the achievement was far more complex. The aircraft faced serious reliability issues and operational challenges that limited its lifespan. Its time in service was short, and it was eventually withdrawn, leaving behind lessons rather than long-term success. Here is the key insight. The Tu-144 proved that supersonic travel was possible, but not yet practical. So the next question becomes unavoidable. How did the world refine this idea into something that actually worked? 9. Concorde. Concorde answered that question with precision and ambition. It became the most iconic supersonic passenger aircraft ever built, cruising at Mach 2 and redefining global travel. Flights between New York and London were cut to under 4 hours, something that still feels remarkable today. But behind the speed was a hidden challenge. The aircraft consumed large amounts of fuel and faced strict restrictions due to its loud sonic boom. Then came the turning point. A fatal crash in 2000, combined with rising costs, led to its retirement in 2003. Now, consider this. A machine that symbolized the future disappeared completely. So why is the industry returning to supersonic flight now? Because the core problem was never speed, it was noise. And that is exactly where the next breakthrough begins. 8. NASA X-59. The NASA X-59 is not designed to carry passengers. Its mission is far more strategic. It exists to solve the sonic boom problem that grounded supersonic travel for decades. Instead of producing a loud, disruptive boom, the X-59 is engineered to create a much quieter sound, often described as a soft thump. This is achieved through its long, narrow shape and carefully controlled aerodynamics. There is another striking detail. The aircraft does not have a traditional forward window. Pilots rely on advanced camera systems to see ahead. Now think about the implications. If supersonic aircraft can fly quietly over land, the entire industry changes. And that possibility leads directly into a powerful collaboration. 7th. Lockheed Martin X-59 Partnership. Behind the X-59 stands Lockheed Martin's Skunk Works, a division known for building some of the most advanced aircraft in history. Their role is not just construction, it is precision engineering at an extreme level, shaping the aircraft to control how shock waves move through the air. This is where science meets execution. Every curve and surface is designed to minimize noise impact on the ground. Here is what makes this important. This partnership connects experimental research to real-world application, bridging the gap between concept and future commercial use. So what happens when private companies take these breakthroughs and begin building their own aircraft? 6. Spike Aerospace S-512. The Spike S-512 represents one of the earliest serious attempts to bring supersonic speed into private aviation. It is designed to travel at around Mach 1.6, significantly reducing travel time for long-distance routes. But the most unusual feature is inside the cabin. Instead of traditional windows, the aircraft uses high-definition screens that display real-time external views. This creates a completely different passenger experience, blending aviation with digital technology. Now pause and consider that shift. From physical windows to immersive digital environments. But Spike is not alone in this space. Other companies are pushing the boundaries even further. 5. Gulfstream Supersonic Research. Gulfstream, one of the most respected names in private aviation, is quietly working behind the scenes on supersonic technology. The company has developed patents focused on reducing sonic boom intensity and improving aerodynamic efficiency. While no supersonic jet has been officially announced, the research itself signals long-term intent. This matters because Gulfstream dominates the business jet market. If it enters the supersonic race, the impact would be immediate and significant. But the implications go beyond private ownership. What if supersonic travel becomes a tool for governments and strategic operations? 4. Exosonic jet. Exosonic is developing a supersonic aircraft designed to operate quietly over land, something previous generations could not achieve. The project has attracted attention from the United States Air Force, which is exploring its use for executive transport. This changes the conversation entirely. Supersonic travel is no longer just about luxury. It becomes a matter of speed, efficiency, and strategic mobility. The aircraft is being designed to combine performance with reduced environmental and noise impact. Now, imagine a future where high-speed travel is not restricted by geography. But for that future to become real, another company has already taken a major step forward. 3. Boom Supersonic Overture. Boom Supersonic is developing the Overture, a next-generation aircraft designed to bring back commercial supersonic travel. It is expected to fly at speeds around Mach 1.7, cutting long-distance travel times significantly. Major airlines have already placed orders and commitments, showing strong industry confidence. Here is what makes it different from the past. The company is focusing on sustainability, aiming to use modern engines and alternative fuels. Now consider this contrast. Faster travel, but with an emphasis on efficiency and environmental responsibility. But before Overture can enter service, something critical had to happen first. 2. Boom XB-1 Demonstrator. The XB-1 is the experimental foundation behind Boom's ambitions. It is a smaller aircraft built specifically to test the technologies required for supersonic flight. It has already completed multiple test flights, gathering real-world data on aerodynamics and performance. This is where theory transitions into reality. Instead of relying on simulations, engineers now have direct flight data to refine their designs. And that data is essential, because without proven results, no aircraft can move forward into certification and production. So what remains as the final barrier? 1. NASA Low-Boom Flight Demonstration Program. 1. NASA Low-Boom Flight Demonstration Program. At the top of this entire movement sits the most critical force shaping the future of supersonic flight. It is not a company. It is not a jet. It is regulation. The NASA Low-Boom Flight Demonstration Program is focused on one objective: changing how the world regulates supersonic travel. For decades, supersonic flight over land has been heavily restricted. The reason is simple. Sonic booms were too loud, too disruptive, and unacceptable for populated areas. This limitation forced aircraft like Concorde to operate mostly over oceans. Now everything is being challenged. Using the X-59, NASA is collecting real-world data on how people respond to quieter sonic signatures. Communities will experience these reduced thumps instead of explosive booms. And here is the turning point. This data will be delivered to global aviation regulators, including authorities responsible for setting international flight rules. If those rules change, the entire structure of air travel shifts overnight. Flights that once had to follow long ocean routes could suddenly cross continents directly at supersonic speeds. Now pause for a moment. This is not just an upgrade. It is a transformation of how distance is experienced. A journey that takes 8 hours today could be reduced to 4. Long-haul travel becomes short-haul in perception. And that is where everything connects. The Tu-144 showed what was possible but unstable. Concorde proved it could work, but not sustainably. The X-59 is solving the noise problem that held everything back. Private companies like Spike and Boom are turning that solution into real aircraft. And governments are preparing to adapt to a new reality. But there is a deeper layer that often goes unnoticed. Supersonic private jets are not just about speed. They are about time as a competitive advantage. For business leaders, governments, and high-level operations, time is one of the most valuable resources. Cutting travel time in half is not just convenient. It changes decision-making, logistics, and global coordination. Now imagine this scenario. A business executive attends meetings across continents in a single day. A government official responds to international events in hours instead of a full day. That level of speed creates a new standard, but it also introduces new expectations. And that is where the stakes rise. Because once supersonic travel becomes available again, it will not remain a niche forever. History shows that technology evolves in layers. What begins as exclusive eventually becomes more accessible. Commercial aviation followed that path. So did private jets. Supersonic travel may follow the same trajectory, but only if the final barrier is removed. And that barrier is not engineering. It is approval. Regulatory bodies must be convinced that low-boom aircraft can operate safely and quietly over populated areas. That process takes time, testing, and global cooperation. But progress is already underway. Flight tests are being conducted, data is being collected, policies are being reviewed, and slowly, the foundation is being built. Now here is the question that defines everything. What happens when the rules finally change? The answer is simple. The race accelerates. Companies that have spent years developing technology will move quickly to bring their aircraft into service. Private jets could be the first to benefit, as they operate in a more flexible and premium market. From there, commercial aviation may follow. And once that happens, the idea of supersonic travel will no longer feel futuristic. It will feel normal. But we are not there yet. Right now, the industry is in a transition phase, a moment where past lessons, present technology, and future ambition are all converging. And that convergence is what makes this period so significant. Because for the first time since Concorde, supersonic flight is not just being remembered. It is being rebuilt.